2 galaxies were discovered with almost no dark matter at all, and that single finding sent shockwaves through the entire field of cosmology, because according to everything we thought we knew, those galaxies shouldn't exist. Here's the thing about dark matter. We've never actually seen it, not once. No telescope has ever captured an image of it, no particle detector has ever directly measured it. And yet, for decades, it has been the invisible scaffolding holding our entire model of the universe together. We believe it exists because of what it does, the way it bends light, the way it makes galaxies spin faster than they should, the way entire galaxy clusters behave as if there's far more mass present than we can see. About 27% of the universe, by our best estimates, is made of this mysterious, invisible substance. The stuff you and I are made of, ordinary matter, accounts for less than 5%. So when astronomers pointed their telescopes at a faint, ghostly galaxy called NGC 1052-DF2 in 2018 and discovered it had almost no dark matter whatsoever, the reaction wasn't just surprise, it was something closer to disbelief. And that's just the beginning, because what they found next pushed things even further. Stay with me. NGC 1052-DF2 is what scientists call an ultra-diffuse galaxy. Picture a galaxy the size of the Milky Way, roughly the same diameter, but with only 1/200th the number of stars. It's enormous and nearly transparent, a cosmic ghost. These ultra-diffuse galaxies were already mysterious objects, but this one was different. When researchers measured the velocities of the star clusters orbiting inside it, they ran the numbers expecting to find the telltale gravitational fingerprint of dark matter. Instead, they found almost none. The galaxy's visible mass alone, its stars, was nearly enough to account for all the gravitational behavior they observed. It was as if someone had built a house with no foundation and it was still standing. Now here's where it gets strange. The standard story of galaxy formation says that dark matter doesn't just support galaxies, it actually seeds them. The leading model of cosmology, called Lambda-CDM, holds that dark matter collapses first under its own gravity, forming invisible halos. Then ordinary matter falls into those halos, cools down, and forms stars. No dark matter halo, no galaxy. It's supposed to be a requirement. So discovering a galaxy that formed and survived without it is like finding a pearl with no oyster. It forces the question, how? There are a few competing ideas. One of them is actually kind of violent. Some researchers think NGC 1052-DF2 might have had its dark matter literally stripped away, torn off by a gravitational interaction with a nearby massive galaxy, NGC 1052, which sits relatively close in the same region of space.
Imagine a gravitational tug-of-war so powerful that the dark matter, which is more loosely bound to the galaxy than the stars, gets ripped away, leaving the stellar body behind like a ship that lost its anchor. It's dramatic, and it's plausible. But here's the twist. In 2019, astronomers found a second galaxy with the same bizarre property, NGC 1052-DF4. Same region of sky, same ultra-diffuse structure, same near-total absence of dark matter. And then more were found. At last count, researchers have identified dozens of these anomalous galaxies. The stripping hypothesis might explain one or two. It doesn't easily explain dozens, which means something else might be going on, something we haven't fully worked out yet. That unresolved question is sitting right at the heart of modern cosmology. Now, step back and think about what this means for the bigger picture, because the implications aren't small. For decades, there has been an alternative to dark matter called MOND, Modified Newtonian Dynamics. The basic idea is that instead of adding invisible mass to the universe, you modify the laws of gravity themselves at very large scales. It's a minority view, but it has real scientists behind it, and it has successfully predicted certain galactic behaviors that dark matter models struggle with. The existence of dark matter-free galaxies, at first glance, looked like a killing blow to MOND. If dark matter doesn't exist, how can there be galaxies with none of it? That seems to vindicate dark matter. But, and this is the part that keeps theorists up at night, MOND also has serious trouble explaining these galaxies, because its modified gravity equations predict that low-density galaxies should behave in a specific way, and dark matter-free galaxies don't quite do that either. So both frameworks are under pressure. Neither one cleanly survives contact with these objects. What we're watching, in real time, is a field of science being forced to evolve, not because a theory was proven wrong in a lab, but because the universe produced something that doesn't fit any of the boxes. That is how science actually progresses, not in smooth, triumphant steps, but in moments of genuine confusion, followed by hard thinking, followed by a better question. Here is the perspective shift I want to leave you with. The universe is under no obligation to be simple. For a long time, we assumed that dark matter was everywhere, that every galaxy was embedded in it, that the cosmos was uniformly woven with this invisible fabric. These ghost galaxies shatter that assumption. They tell us the universe is more varied, more surprising, and more structurally complex than our tidiest models allowed. Some galaxies are made almost entirely of dark matter, so diffuse and visible stars they're nearly impossible to see. Others apparently contain almost none. The universe, it turns out, is not a single recipe repeated at scale.
It's more like an ecosystem, wildly diverse, full of exceptions, and endlessly capable of producing something that makes you rethink everything. We don't yet know exactly what these dark matter-free galaxies are telling us. That's not a failure. That is the frontier. And the fact that a single, faint, ghostly smear of stars 65 million light-years away can throw our best cosmological models into question is honestly one of the most exciting things happening in science right now. If this video expanded your view of the cosmos, hit like. It genuinely helps this channel reach more curious minds. Subscribe so you don't miss what's coming next, and drop a comment below. Do you think dark matter is real, or do you think gravity itself needs to be rewritten? I read every response. Next time, we're going somewhere even stranger, a place in the universe where the rules of space and time don't just bend, they break entirely.